Good evening everyone, good evening. Welcome back, my dear JEE enthusiasts. Hope that you guys are doing great. Well, you can let me know in the chat box if I'm audible and visible to everyone. Gayatri, I'm feeling a little better. Hi Nidhi, I'm doing great, how are you? Hello Lipika, hello Aditi. Hello Shivam, hi Sid, hi Priyanka. Hi Preeti, hello Ishani, hi Shivam. Hi Audesh, hello Bhumika. Hi Nandita, hello Shrey. Well, just let me know in the chat box if I'm audible and visible to everyone. Yeah, just give me some green signal from the chat box. Thank you Manoj. Manoj is my long-term batch student. Yeah, welcome Manoj, welcome. Perfect. Hi Arshil, welcome everyone, welcome. So people, I'll be sounding a little low tonight, yeah, because I'm not completely well, right? My throat is a bit aching, yeah? I hope you can understand. Perfect. So people, this is going to be the last session of the mole concept, yeah? In the last session of it, what did we do? We did the empirical and molecular formula. And tonight, we are going to do the previous year asked questions from this chapter, okay, in your mains examination, right? We are going to see all the questions which have been asked from this chapter in your JEE Mains, correct? So before starting the session, the ones who are new to the channel, let me introduce myself. My name is Wassim Sir, and I'm your chemistry master teacher right here on this channel, yeah? Mayank, this is the English channel. I'm not supposed to talk in Hindi. You should read the name of the channel. It's Vedantu JEE English, yeah? Perfect. Well, for the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. And do not forget to hit the bell icon so that you get the notification of every single session which will be taking live on this JEE Enthuse, right? Yes, Bushra, you can join the course. Why not? The link is there in the description box of the video. Click on that link, get added to the actual Vedantu platform. There you'll be getting trained by me, okay? Naveen, the questions are going to be from JEE Mains, right? Perfect. So you can let me know in the chat box if you guys are super duper excited about the session. Yes, just give me some thumbs ups, give me some green signal from the chat box so that I'll get to know whether you guys are super duper excited about it or not. Hello Santosh, how are you doing? Shreya, I'm a little better. Okay, so let me know in the chat box if you guys are super duper excited about the session, right? You must be, because it's going to be the previously asked questions from the chapter mole concept, right? And if you have watched the entire video lectures of this mole concept chapter, I'm sure you can solve all these questions which have been asked till now from this chapter in your JEE Mains examination, right? Perfecto. So let's move on to the first question, which is on your screen now. Yeah, the question was asked in JEE 2020. Right? This is the question on the screen, and I'm damn sure you guys can kill this question if you have watched the first session of the mole concept. Yeah? So let's look at the question. Let's see what we are supposed to calculate and what all things are given to us. Right? See guys. As per the question, the average molar mass of chlorine is given to me as 35.5 grams per mole. The ratio of Cl35 to Cl37 in naturally occurring chlorine is equal. So basically, what am I supposed to calculate as per the question? I'm supposed to calculate the ratio of percentage abundances of the isotopes of chlorine. Understand properly, guys, what is given in the question and what we are supposed to calculate, yeah? Exactly, Shreya, you're right. A lot of people have already given the answer, but still, let's see how this question was to be solved. Understand. See, you all must be knowing chlorine, it has got two isotopes, right? One is your Cl35, another one is Cl37, right? These are the two isotopes of chlorine, yeah? I'm representing the average atomic mass of chlorine by MAV, correct? Right? Let's assume the percentage abundance of this Cl35. Let's assume the percentage abundance of Cl35 is something as X%. So I can clearly say the percentage abundance of Cl37 is simply going to be 100 minus X%, right? Because we know, if you remember, the sum of percentage abundances of all the isotopes of a particular element, that's always equal to 100, right? So basically, I have got two isotopes of chlorine whose percentage abundance I'm assuming to be X% and 100 minus X, right? Now people understand. I can call this value simply as M1. I can call this value simply as M2, right? And if you remember, we used to represent these percentage abundances by A and B, right? So I can clearly use the formula of M average. How do we calculate average atomic mass for the element which exists in the form of isotopes? It's simply going to be M1 multiplied by A plus M2 multiplied by B divided by A plus B, right? So it's going to be M1 multiplied by A plus, let me write it somewhere here. I'm not getting a space properly over here. Just give me a second. So I'll be writing it over here, right? M average, it's going to be equal to M1 multiplied by A. That means 35 multiplied by X plus M2 multiplied by B, which is going to be 37 multiplied by 100 minus X divided by A plus B. A plus B value, sum of percentage abundances of all the isotopes is always equal to 100, right? Well, people, this value is given as per the question and it's given to me as 35.5, right? It's given to me as 35.5. Well, if you look at this equation, in this equation you have got just one variable, that's X. Can we get the value of X from here? Absolutely. When you'll simple cross multiply this, you'll be getting the value of X from here as 75%. That means the remaining is going to be 100 minus X. So what was X first of all? X was basically the percentage abundance of this Cl35, which I used to represent by A. So I got the percentage abundance of Cl35 as 75%, right? Similarly, it is going to be 100 minus X. 100 minus 75 comes out to be 25%. So I got the percentage abundances of these two isotopes. What am I supposed to calculate? I'm supposed to calculate the ratio of these percentage abundances. So I'll be simply writing like this. Cl35 is to Cl37, right? What is going to be the ratio of their percentage abundances? It's going to be 75 is to 25, correct? Just convert it into simplest ratio. It's going to be 1 times, it's going to be 3 times. So I got the ratio as 3:1. So I can say the ratio of percentage abundances of these two isotopes is simply going to be 3:1 as per the equation. Yeah? You can just give me some green signal from the chat box if it is clear to everyone. You can just give me some green signal from the chat box so that I'll get, so that I'll get to know whether you got it or not. Yeah? Simply, I use the formula to calculate average atomic mass of the isotopic mixture. Right? From there, I got the percentage abundances of these isotopes. And once you get the percentage abundances of these isotopes, you just have to take the ratio of the percentage abundances of these two isotopes. You'll be getting the exact ratio of percentage abundances of these isotopes, right? Yes? Perfect, guys. Perfect. Right? All right. I'm moving on to one more question. This is one more question on your screen. The question was asked in JEE 2019. Okay? See guys, a very simple question. Understand, you just need to understand the language of the question. That's it. Okay? The percentage composition of carbon by mole in methane. Okay? So basically, I'm going to check the percentage of carbon by mole in methane. What does that mean? See guys, what that means. Remember, percentage of carbon by mole in methane. It's going to be equal to number of moles of carbon present in methane divided by total moles multiplied by 100. This is the simplest formula by means of which I can calculate the percentage of carbon by mole in methane. Similarly, you can write it like this also. If I'll write something as percentage of hydrogen by mole. Let's say I need to calculate the percentage of hydrogen in this methane by mole. It's going to be number of moles of hydrogen in this divided by total moles multiplied by 100. As simple as that. Yeah. What am I supposed to calculate? I'm supposed to calculate percentage of carbon by mole. It is simply going to be equal to number of moles of carbon present over here is 1. Yes. Basically, in 1 mole of methane, there is only 1 mole of carbon, right? I can say like this, 1 mole of methane contains 1 mole of carbon, and at the same time it contains 4 moles of hydrogen as well, 4 moles of H as well, right? So how many moles of how many moles of carbon do we have right here? We have got 1 mole of carbon divided by how many total moles of atoms are there? There are 1 plus 4, that comes out to be 5. So 5 moles are there in total, multiplied by 100, right? Just you'll be getting the value over here as 20%. So the percentage of carbon by mole in case of methane is simply going to be 20%. You can let me know in the chat box if it's clear to everyone. Yeah? Right? Mehul, it's mentioned in the question, we are supposed to calculate the percentage composition of carbon by mole, okay? It's mentioned in the question itself. Yeah? Just let me know in the chat box if it's clear, right? Just remember the formula. This is how you calculate percentage of the element by mole in a compound. That's it, right? Similarly, if you were supposed to calculate like this, see guys, understand one more thing. If you were supposed to calculate, for example, the percentage of hydrogen by mole in methane, it would have been equal to number of moles of hydrogen present in 1 mole of methane, that's 4, divided by total moles present over here, that is 4 plus 1, 5, multiplied by 100, correct? The value would have been come as 80%. So percentage of hydrogen in methane by mole is simply going to be 80%, correct? As simple as that, right? Exactly. Anything could have been asked from the question. Perfect. So let me know in the chat box if it's clear to everyone. Yeah? Let me know in the chat box if it's clear to every single guy. Let me know in the chat box so that I can move on to the next one. Right? Just give me some green signal from the chat box so that I'll get to know whether you got it or not. Chinmay, I'll be letting you know about that as well. Just wait. Perfect, guys. Let's move on to one more question. This is one more question over here. Yeah? What is the question all about? What is the question all about? 25 grams of an unknown hydrocarbon upon burning produces 88 grams of carbon dioxide and 9 grams of water. This unknown hydrocarbon contains, okay, this is the question, and the question was asked in JEE 2019. That means 2 years back, right? See guys, a very simple question. You just have to understand the language of the question and use the common sense a bit. That's it. Yeah? See how I'll try to approach this question. Understand properly what I'm going to say. See guys, basically I'm given with an unknown hydrocarbon, CXHY, yeah? And as per the question, I'm burning this hydrocarbon. That means I'm doing the combustion of this hydrocarbon. What does that mean? That means I'm making this hydrocarbon to react with oxygen. And if you remember, I have told you, combustion of hydrocarbon always leads to the formation of carbon dioxide gas and H2O gas, right? So over here, you'll be first of all getting the product as carbon dioxide gas. And with this carbon dioxide gas, you'll be getting H2O gas as well. Yeah? First of all, I have told you how to balance this combustion reaction of hydrocarbon as well, if you remember. See, right here there is X. Stoichiometry coefficient of carbon dioxide will be X. Stoichiometry coefficient of water is going to be Y divided by 2. Stoichiometry coefficient of oxygen is going to be simple X plus Y divided by 4, right? This is the balanced form of the reaction. This is the balanced form. This is the balanced chemical equation, right? And I've told you in detail how to balance this over here, yeah? Now we will understand. See what all parameters are given to me. 25 grams of an unknown hydrocarbon. I'm given with 25 grams of this unknown hydrocarbon, right? I'm given with 25 grams of this unknown hydrocarbon. As per the question, when 25 grams of this unknown hydrocarbon, it undergoes combustion, it produces 88 grams of carbon dioxide. It produces 88 grams of carbon dioxide and we get some 9 grams of water as well as per the question. We get some 9 grams of 9 grams of water as well as per the question, correct? Now we will see how I'll be solving this sort of equation. Understand properly. See, just have a look. On the reactant side, carbon is present only in this compound, right? Carbon is not present right here. Similarly, hydrogen is only present in this compound. Hydrogen is not present right here. How many atoms of carbon do we have? X. In the product, how many atoms of carbon do we have right here? Again, X atoms of carbon, right? So can I say whatever carbon will be there in this hydrocarbon, that entire carbon is finally reaching into carbon dioxide? As simple as that. Similarly, whatever amount of hydrogen will be there, whatever amount of hydrogen will be there in this hydrocarbon, that entire amount of hydrogen will be finally reaching into this water, right? As simple as that. whatever amount of carbon, whatever mass of carbon will be there in this hydrocarbon, that entire amount of carbon is reaching into the carbon dioxide. So the amount of carbon in carbon dioxide is going to be same as that of amount of carbon in this hydrocarbon. Number one. Number two, the amount of hydrogen in this hydrocarbon is going to be exactly same as the amount of hydrogen present in this water. Yeah? Right? Now people see what I'll be doing over here. Very simple thing, understand. So if I simply get to know how many grams of carbon are there in carbon dioxide, that actually means I'll be getting the grams of carbon present in hydrocarbon, because we know whatever grams of carbon will be present right here, same grams of carbon will be present right here. Similarly, whatever grams of hydrogen will be present right here, same grams of hydrogen will be present right here in this compound as well. As simple as that, right? Now see what I'll be doing. Understand properly. See guys, if I talk about carbon dioxide, if I take 1 mole of carbon dioxide, for example, 1 mole of carbon dioxide, can I say 1 mole of carbon dioxide contains 1 mole of carbon? I can say this. Just see the approach of how to solve these sort of questions. Can I say 1 mole of carbon dioxide contains 1 mole of carbon, right? What is the mass of 1 mole of carbon dioxide? Mass of 1 mole of carbon dioxide is what we call as molar mass of carbon dioxide, right? What is the molar mass of carbon dioxide? 44 grams. So can I say 44 grams of carbon dioxide? 44 grams is the mass of 1 mole of carbon dioxide, right? So I can say 44 grams of carbon dioxide will contain 1 mole of carbon dioxide means 12 grams of carbon dioxide. 12 grams is basically the mass of 1 mole of carbon. 12 grams is the mass of 1 mole of carbon, or you can say 12 grams is the molar mass of carbon. So as per the normal stoichiometry, I got to know something like this. 44 grams of carbon dioxide contains 12 grams of carbon. So can I say 1 gram of carbon dioxide will contain 12 divided by 44 grams of carbon? Yeah, absolutely. 1 gram of carbon dioxide will be containing these many grams of carbon. And over here we have got 88 grams of carbon dioxide. Can I say 88 grams of carbon dioxide will be containing 12 divided by 44 multiplied by 88? Value will come out to be 24 grams of carbon. So I got to know something like this. I got to know in these 88 grams of carbon dioxide, there will be 24 grams of carbon. And as I told you, entire carbon which is there in carbon dioxide, that is coming from this hydrocarbon, right? So whatever carbon is present in carbon dioxide, same amount of carbon will be there present in this hydrocarbon. So I got to know in this hydrocarbon, there are some 24 grams of carbon present. There are some 24 grams of carbon present, right? Okay. What was the total mass of hydrocarbon? It was 25 grams. Out of 25 grams, 24 grams of carbon are there. So how many grams of hydrogen will be there? It is simply going to be 1 gram of hydrogen. Yeah, as simple as that. So I got to know in these 25 grams of hydrocarbons, there will be 24 grams of carbon and 1 gram of hydrogen. That's something which I was supposed to calculate, which is going to be option C. Yeah. You can just let me know in the chat box if it's clear to everyone, and do not forget to like the video if you got the concept. Yeah. Goklish is saying, sir, why we are taking it as? I'm not getting you, Goklish. What are you saying? Okay, just elaborate a bit. I'm not getting what you're saying exactly. Perfect. Just give me some green signal so that I'll get to know whether you got it or not. And directly I'll move on to the next one. Yeah? Wonderful. So people, let's move on to one more question. Yeah? Let's move on to one more question. This is one more question which was asked in JEE 2019, right? From the same chapter. And I'm sure all of you can kill this question. Trust me on that. See, what am I given with and what am I supposed to calculate? Understand. See guys, 8 grams of NaOH is dissolved in 18 grams of water, right? I'm putting some 8 grams of NaOH in 18 grams of water. So just have a look. Can I say water is present in larger amount? So water is simply going to be my solvent, right? So I got to know water right here is my solvent because it's present in larger amount. And this NaOH, it's going to be my solute, right? NaOH is going to be my solute because it's present in lesser amount, yeah? I hope you remember, solvent we used to represent by number 1, solute we used to represent by number 2, right? Well, I'm given with the mass of NaOH. That means I'm given with the mass of solute, which I represent by W2. It's given to me as 8 grams. correct? I'm given with the mass of solvent, which I'm representing by W1. Mass of solvent, mass of water, it's given to me as 18 grams. What am I supposed to calculate? First of all, I'm supposed to calculate mole fraction of NaOH in the solution. Mole fraction of NaOH in the solution, right? So, mole fraction of NaOH means mole fraction of solute. Can I say mole fraction of solute is actually equal to number of moles of solute divided by total moles present in the solution, right? Yeah, I can say that. Correct? Now, in order to calculate this mole fraction of solute, I should know the value of N1, I should know the value of N2. And now it is the time to calculate N1 and N2. Then I'll be putting the values into this equation. I'll be getting the mole fraction of solute, yeah? Right? Naman, this is the English channel, okay? This is the English channel, right? This is not, I'm not supposed to talk in Hindi. The name of the channel is JEE English, right? Okay, now we will see. Let's try to get the value of N2 first. What is N2? Number of moles of solute. Number of moles of solute is going to be equal to mass of solute divided by molar mass of solute. What is the molar mass of NaOH? That's 40. The value comes out to be 1 by 5. Now let's calculate N1 value, number of moles of solvent. It's going to be equal to mass of solvent, which is 18 grams, divided by molar mass of solvent. Molar mass of water again is 18. The value comes out to be 1. Well, I got the value of N2, I got the value of N1. The question is done and dusted, right? I got the value of N2, I got the value of N1. What is the value of N2 which you are getting right here? You are getting the value of N2 as 1 by 5. N1 value you got simply as 1 plus 1 divided by 5. Can you solve it and let me know the answer exactly what is coming from here? Can you solve it for me fast? I think it will be 0.167, right? Yeah? Right? Okay, so I believe it's going to be some 0.167. You get the mole fraction of solute right here as 0.167. Now people understand. I got the first part of the question done. Mole fraction of solute is done. Now the second part of the equation, we are supposed to calculate molality of the solution. Yeah? If you remember, I gave you one direct result between molality and mole fraction. If you do not remember, then remember from now onwards. Molality is equal to mole fraction of solute multiplied by 1000 divided by 1 minus mole fraction of solute multiplied by molar mass of solvent. Yeah, this was one direct result which I gave you if you remember. Yeah, mole fraction of solute I got to know as 0.167 multiplied by this 1000 divided by 1 minus chi2. 1 minus 0.167 multiplied by M1. What is M1 over here? M1 is the molar mass of solvent. Solvent is water. And what is the molar mass of water? That's 18. When you will solve this, I think you get the value something as 11.11. So 11.11 is basically the molality of the solution, which was the second part of the equation. I'm sure it's clear to everyone, yeah? Right? I got the mole fraction of solute. I got the molality of the solution. Now, which option satisfies it? It's done and dusted, right? Option 4 satisfied it, right? Exactly. Exactly, guys. Wonderful. Perfect, guys. Okay. So just give me some green signal from the chat box so that I'll get to know whether you got it or not. Just give me some green signal from the chat box so that we can solve one more question. A very simple question. This was asked in your JEE 2019, right? The question was asked in your JEE 2019. Abhijit, it is WSPRO, okay? WSPRO. Wassim Sir's Pro subscription. Link is there in the description box of the video. Okay, now let's try to solve this question as well. See guys how this question is to be solved. Again, it's a simple question. You need to understand the language of the question as I keep on telling you all the time, yeah? See, look here guys, properly look. A solution of sodium sulfate. I've got some solution of sodium sulfate, right? Right, Na2SO4. I've got some solution of sodium sulfate. That contains 92 grams of Na positive ions per kg of water. So I've got a solution that contains 92 grams of Na positive in 1000 grams of water, right? So it's mentioned in the question 92 grams of Na positive are present in 1000 grams of water. Yeah, this is something which is mentioned as per the question. We are supposed to calculate the molality of Na positive in the solution. We are supposed to calculate molality. Guys, do you remember the formula for molality? Simple. Mass of solute in grams, which I represent by W2, multiplied by 1000, divided by molar mass of the solute multiplied by mass of solvent in grams. I hope you remember this formula. By means of this formula, we can calculate the molality of the solution. Yeah? Now people understand. W2. W2 is simply going to be mass of Na positive, which is given to me as 92 grams. Mass of Na positive, because I'm supposed to calculate molality, right? The molality of Na positive ions, right? So I'm treating this Na positive as solute. I'm treating this Na positive as solute, as simple as that, okay? Now, mass of solute, mass of this Na positive is 92 grams multiplied by 1000 divided by molar mass of this Na positive. What is the molar mass of sodium? It's 23 grams. Remember, due to the presence of charge, there will be no effect on the molar mass of sodium. See, if you write Na sodium, if you write Na positive, correct? Due to the presence of the charge, there will be no effect on the molar mass. Remember it, okay? Yeah, molar mass of sodium is 23 grams per mole. Even this is going to be 23 grams per mole. No issues at all, yeah? Okay, so M2 value is simply 23 multiplied by mass of solvent. Mass of solvent, that is mass of water, which is going to be simply 1000. This and this got cancelled. The value comes out to be 4. So you got to know molality of Na positive in the solution is 4. Yeah? If I ask you, what does it exactly mean? It exactly means 4 moles of Na positive are present in 1000 grams of solvent, 1000 grams of water. Yeah? Just let me know in the chat box if it's clear to everyone. The option, correct option is going to be option number 2, right? Just let me know, give me some green signal from the chat box so that I'll get to know whether you got it or not. Yeah? Give me some green signal from the chat box. Give me some green signal from the chat box, yeah? Fast, guys. And the ones who have not liked the video yet, please and please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, yeah? Perfecto. Wonderful. Wonderful. The option is going to be option 4, yeah? Okay. Moving on. We have got one more question right here, and the question was asked in JEE 2017 from the same chapter. Look at it carefully and just use your common sense a bit, right? The question will be done and dusted. See how I'll be trying to solve this question. Yeah? Okay. So people, look here. As per the question, 1 gram of carbonate. This is the carbonate which is given to me, M2CO3, right? As per the question, I have got 1 gram of M2CO3. I have got 1 gram of some metal carbonate, for example. On treatment with HCl, so this metal carbonate, it's reacting with HCl, yeah? Produces 0.0118 moles of carbon dioxide. Okay, I'm already given with the reaction, right? Why am I writing it again? See, metal carbonate, it's reacting with HCl, leading to the formation of metal chloride. With this, you get water and carbon dioxide as well, right? As per the question, how many grams of metal carbonate do I have? As per the question, I've got some 1 gram of metal carbonate. Yeah, I've got some 1 gram of metal carbonate, right? When 1 gram of metal carbonate reacts with HCl, it leads to the formation of what? It leads to the formation of carbon dioxide, right? And how many moles of carbon dioxide are getting formed? As per the question, the number of moles of carbon dioxide which are getting formed over here as per the reaction is 0.01186. So these many moles of carbon dioxide are getting formed when 1 gram of this metal carbonate is reacting with HCl as per the question, right? So what am I supposed to calculate? I need to calculate the molar mass of metal carbonate right here. Let's assume something like this. Let's assume molar mass of this M2CO3 is M, okay? Let's assume molar mass of this M2CO3 is M. M is the molar mass of the compound. M is the molar mass of metal carbonate, right? I'm given with the mass of metal carbonate. I know its molar mass, that's M, right? So first thing which I'll be doing, I'll be calculating number of moles of metal carbonate. Number of moles of metal carbonate is going to be equal to mass of metal carbonate divided by molar mass of metal carbonate. So basically these many moles of metal carbonate I have right now with me, and I'm making these many moles of metal carbonate to participate in this reaction. Yeah? Okay. See people, how will I be solving this? Understand. Yeah? Now, the reaction is balanced. The reaction is balanced, right? See, the stoichiometry coefficient right here is 1. The stoichiometry coefficient right here is 1. Can I say something like this? 1 mole of metal carbonate produces 1 mole of carbon dioxide. Yeah, as per the stoichiometry of the reaction, I can clearly say 1 mole of metal carbonate produces 1 mole of carbon dioxide. So, do I have 1 mole of metal carbonate? No, I have got 1 by m moles of metal carbonate. If 1 mole of metal carbonate is producing 1 mole of carbon dioxide, I can say 1 by m moles of metal carbonate will produce 1 divided by m moles of carbon dioxide. So as per the stoichiometry, I got to know these many moles of carbon dioxide should get produced, right? So as per the stoichiometry, I got to know number of moles of carbon dioxide that should get liberated is equal to 1 by m. But am I given with the number of moles of carbon dioxide which are getting liberated, right? I'm already given with this term, which is 0.01186. So number of moles of carbon dioxide liberated is already given to me, which is 0.01186. So this is equal to basically 1 by m. So from here, I get the value of m as 1 divided by 0.01186, and you get the value right here as 84.3, right? So there 84.3, this is basically the value of m. And what was m all about? M was the molar mass of this metal carbonate which I was supposed to calculate as per the equation, right? Yeah. Rajat, sometimes the equation can be given to you, sometimes it cannot be given to you as well, okay? Yeah. It's simple. When metal carbonate reacts with HCl, leads to the formation of metal chloride, right? Okay. Just give me some green signal from the chat box so that I'll get to know whether you got it or not. Give me some green signal from the chat box. And if you got the concept, do not forget to subscribe to the channel. Do not forget to like the video as well. Yeah. Right? Perfecto. Wonderful. Let's move on to one more question. See guys, this is one more question. The question was asked in JEE 2014 and IIT 1979. My God, long back. See guys, how this question is to be solved. It's a very simple question. It's a very, very, very simple question, right? See guys, what I'll be doing. The ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1:4. Look at the question carefully, understand the terms which are given in the question. The ratio of masses of oxygen and nitrogen, right? So basically, I'm given with the ratio of the mass of oxygen to the mass of nitrogen. I'm given with this ratio as per the question. It's 1:4. Correct? What am I supposed to calculate? I'm supposed to calculate the ratio of the number of their molecules. The ratio of the number of their molecules. Remember one important thing. Whatever is going to be the ratio of their moles, same is going to be the ratio of their molecules. As simple as that. See, I'm given with the ratio of the masses of these gases over here, which is 1:4 as per the equation. Yeah. Now people, what I'm telling you, whatever is going to be the ratio of their moles, same is going to be the ratio of their molecules. Yeah. So if I somehow got the ratio of their moles, that is automatically going to give you the ratio of their molecules as well. Yeah. Understand what I'm going to do? I'll write mass of O2 divided by mass of N2, right? It's given to me as per the question as 1 divided by 4, right? This is something which is given to me, correct? Now people see. I'll write number of moles of oxygen divided by number of moles of N2. This is basically the ratio of the moles of O2 and N2. And as I told you, whatever is going to be the ratio of moles of O2 and N2, same is going to be the ratio of their molecules. As simple as that, right? Number of moles of O2 is going to be equal to mass of O2 divided by molar mass of O2. Yeah, whole divided by. Number of moles of N2 is going to be equal to mass of N2 divided by molar mass of N2. Yeah, very simple. Now just rearrange this equation. I'll write it as mass of O2 divided by. It's going to be mass of N2 in the denominator, and over here you get mass of O2, and in the numerator you get mass of N2 while writing it. Okay. See guys, just see one thing. Can you see you are given with this value already? Mass of O2 divided by mass of N2. This value is already given to me as 1/4, right? So I'll write 1 divided by 4. Instead of this term, I'll writing 1/4 multiplied by. What is the molar mass of N2? Molar mass of N2 is 28 grams per mole. What is the molar mass of O2? That is 32 grams per mole. This is 4:1. This is 4:7. So you get the value as 7 divided by 32. So if I ask you, what is the ratio of the moles of O2 and N2 which you are getting over here? The ratio of moles of O2 and N2 you are getting to know as 7:32, right? As simple as that. And I told you in the beginning itself, whatever is going to be the ratio of the moles of these gases, same is going to be the ratio of their molecules, right? Yes. Because when I'll be calculating the molecules, Avogadro's number will be cancelled out. So the rest of the molecules will be coming out to be same, right? Yes, give me some thumbs ups in the chat box so that I'll get to know whether you got it or not. Give me some thumbs ups, give me some green signal from the chat box so that I can move on to the one more question. Yeah? Right? Fast, guys, fast. Give me some green signal fast, yeah? Perfect, guys. Wonderful. Okay. So let's move on then. Let's move on to one more question. Let me see if you can solve that or not, yeah? This is the question. A very, very simple and ordinary question. The question was asked in JEE 2013, right? Right. See, guys, how this question is to be solved. The molarity of the solution obtained by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl, correct? People, molarity of mixing, as simple as that, right? We have discussed this in detail, right? Whenever I'll be adding two non-reacting solutions, the molarity of the resulting solution is given by the formula simple M1V1 plus M2V2 divided by V1 plus V2. I hope you remember this. No need to think a lot for this question. You are given with all the parameters. Just put all these parameters into this equation, you are done, right? Yes. Okay, see guys, what is the value of M1? M1 is the molarity of the first solution, that is 0.5. What is the value of V1? V1 is 750, correct? What is the value of M2? M2 is something 2, right? What is the value of V2? V2 is 250, correct? Divided by V1 plus V2. V1 plus V2. V1 is 750, V2 is 250. So 750 plus 250 comes out to be 1000. Just solve it. Let me know the exact value which you are getting from here. Let me know the exact value which you are getting from here. Well, people are saying it's coming as 1. Is that? Should I be believing on you? Yeah? So people are saying it's coming out to be 1. So I trust you. It's not 1, it is 0.875, right? When you do the calculations, it will come out to be 0.875 molar over here, right? You have done some calculation mistake. Yes? Perfecto. Just give me some thumbs ups in the chat box. Give me some green signal from the chat box so that I'll get to know whether you got it or not, so that I can directly move on to one more question. Yeah? It was a very simple and ordinary question, right? If you just remember the formula, you're done, right? No need to think about anything else. And if you got the concept, do not forget to subscribe to the channel, yeah? Do not forget to like the video as well. Well, people, this is one more question. The question was asked in IEEE 2012, right? In 2012, at that time, there was not JEE Mains, JEE Advanced. It used to be IEEE and IIT. IEEE was called as JEE Mains and IIT was called as JEE Advanced, right? Okay. See guys, this question already we have solved in our regular session as well, if you remember. This question we have already solved in our regular session as well. But still, let's try it out. Let's try it out once more, yeah? So that you get familiar to these sort of questions. See guys, what the question says and how it's to be approached. That's important. The approach of this question is important. See, the density of the solution prepared by dissolving 120 grams of urea in 1000 grams of water. So as per the question, I'm dissolving 120 grams of urea in 1000 grams of water. Can I say urea is lesser in amount? So urea is going to be my solute. Urea is going to be my solute and water is going to be my solvent. Solute I represent by 2, solvent I represent by 1. I'm given with the mass of solute which I represent by W2, it's 120 grams. Yeah? And I'm given with the mass of solvent as well, which I represent by W1, it's given to me as 1000 grams. Yeah? So I'm given with mass of solute as well as mass of solvent, right? Now people understand. Solute is urea. What is the formula for urea? Remember, the molecular formula of urea is NH2CONH2. If you calculate its molar mass will be coming out to be 60 grams per mole, right? Its molar mass will be coming out to be 60 grams per mole. So basically, molar mass of solute, which I represent by M2, it is 60 grams per mole, right? So as per the question, when you are putting 120 grams of urea in 1000 grams of water, you are getting a solution, and density of that solution is given to me. Density of that solution is given to me as 1.15 grams per ml, correct? What am I supposed to calculate? I'm supposed to calculate molarity of the solution. Yeah. See guys, how will I be solving it? Molarity I need to calculate, right? What is the simplest formula to calculate molarity? Molarity is nothing. Mass of solute in grams multiplied by 1000 divided by molar mass of solute multiplied by volume of solution in milliliters. This is volume of solution right here. If you remember, this is the formula to calculate molarity, right? Now we will see, understand. First thing, see what all parameters are given to me. See, in order to calculate molarity, I need W2, I need M2, I need V. See, among these parameters, what all parameters already I have. I have the value of W2, 120. I have the value of M2, that's 60. But I do not have this volume of solution. Now, it is a point. Now, it's the time to calculate the volume of the solution. The point is how to calculate the volume of the solution, right? In order to calculate volume of the solution, I'll be using this parameter. See, as per the equation, density of the solution is given to me as 1.15 grams per ml, right? Absolutely. People, density of the solution. So instead of density of solution, can I write mass of solution divided by volume of solution? It's given to me as 1.15 grams per ml actually, yeah? If I ask you, what is the mass of the solution? Can I say mass of the solution is going to be mass of solute plus mass of solvent? So this term plus this term, it is going to give me the mass of the solution. So 120 plus 1000, that comes out to be 1120, right? So mass of the solution is basically 1120 grams divided by volume of solution is equal to 1.15, correct? So people, I think you got it, right? You'll be getting the volume of the solution from here as, let me write it like this, 1.15 over here and volume of solution in milliliters you got right from here, right? So this is the volume of the solution which I got. Is this something which I was supposed to calculate? Yeah. Why? Because I need this term into this equation. Well, W2 value is given to me 120, M2 is given to me 60, volume of the solution is this one, right? Put it over here, you get the molarity of the solution after solving as 2.05, yeah? You can clearly tell me what is the meaning of the molarity of the solution over here. What does it mean? It means 2.05 moles of solute, which is urea, 2.05 moles of urea are present in 1 liter of the solution, yeah? Correct? Right? Let me know in the chat box fast. Thunderbird, that's something which I'll be teaching you in redox. I did not teach you the equivalent mass yet. The question which you are saying that vapor density of the metal chloride is this much, its oxide contains something percentage of metal, find the atomic mass. This is something which I'll be teaching you when I'll teach you equivalent mass, okay? Right? Just give me some thumbs ups in the chat box so that I'll get to know whether you got it or not. Right. Abhishek, you have got a lot of time. Just solve all the questions. Whatever questions are there in MS Chavan, solve it. Right? Chinmay, this is the generalized formula to calculate molarity. Yeah? Perfect? Wonderful. Let's move on to one more question. Let's see if we have more questions. Yeah, we have got one more question, guys. Okay. The question was asked in AIEEE 2006. That means JEE Mains 2006, the question was asked. Right? Okay. See what the question says. It's a very simple question, provided you understand the language of the question. That's it. Okay. Provided you understand the language of the question. How many moles of magnesium phosphate, that is Mg3PO4 whole twice, will contain 0.25 moles of oxygen atoms? Yeah? That's something we need to calculate, right? Thunderbird, can you please stop spamming? I'm teaching something else, you're asking something else. When I'll teach you equivalent mass, you come up with whatever questions you have from the equivalent mass, but not now, okay? I've not taught equivalent mass yet, just wait for it. When I'll be teaching equivalent mass, at that time I'll be showing you all the patterns of the questions in equivalent mass, but not now. Stop spamming. Okay. How many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? See guys, how this question is to be solved. So basically we have got something called as magnesium phosphate. Its formula is Mg3PO4 whole twice, yeah? We need to check how many moles of this magnesium phosphate will contain 0.25 moles of oxygen atoms? See how this question is to be solved. Understand. If I'll be having some 1 mole of magnesium phosphate, Mg3PO4 whole twice, yeah? Can I say 1 mole of magnesium phosphate contains 4 2s are 8. Can I say it contains 8 moles of oxygen atoms? As simple as that, right? Yes. From the stoichiometry, I can clearly say 1 mole of magnesium phosphate contains 8 moles of oxygen atoms, right? Yeah? People, I can reverse the statement as well. See, I can reverse the statement as well. You need to play with these statements, right? I can reverse the statement. I can say 8 moles of oxygen atoms. 8 moles of oxygen atoms are present in 8 moles of oxygen atoms are present in 1 mole of magnesium phosphate, Mg3PO4 whole twice. I can say this, right? I just reversed the first statement. I said 8 moles of oxygen atoms are present in 1 mole of magnesium phosphate. Can I say 1 mole of oxygen atom will be present in 1 divided by 8 moles of magnesium phosphate, right? 1 mole of oxygen atoms will be present in 1 by 8 moles of magnesium phosphate. So I can clearly say, using unitary method, 0.25 moles of oxygen atoms will be present in 1 by 8 multiplied by 0.25 moles of magnesium phosphate, right? So this 0.25 is basically 1 by 4. So when you solve this, you get this value after solving as something 3.125 into 10 raised power minus 2. Okay, what does it mean? What does it mean? It simply means 3.125 into 10 raised power minus 2 moles of magnesium phosphate will be containing 0.25 moles of oxygen atoms. Yeah, right? That's something I was supposed to calculate. I was supposed to calculate the moles of magnesium phosphate that contains 0.25 moles of oxygen atoms. And I got to know from this normal stoichiometry as these many moles of oxygen atoms, these many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms, right? Yes, as simple as that. Just give me some green signal from the chat box so that I'll get to know whether you got it or not. Shivam, volume contraction is something which we'll be studying in idiometry, okay? That's something which is not done yet. There'll be some separate sessions on idiometry and everything, okay? Just try to solve these questions. That's it. Yes, Balaji, will be doing atomic structure the next most probably. Okay, let's see if we have more questions. Yeah, we have got one more question. And people, this question is going to be your homework. You guys are going to do this question. I'm not going to do this question because it's a very simple question. This is going to be your homework, right? Number of atoms in 560 grams of iron is twice that of 70 grams of nitrogen, half that of 20 grams of hydrogen, both 1 and B, none of these, right? You guys are going to give it a try and you guys are going to let me know the answer of this question in the comment box once the session ends, yeah? I'm not going to show you this question because it's a very simple and ordinary question. I've shown you these sort of questions in detail, yeah? Just have a look on this question. If you remember, this question already we have solved. The question was asked in somewhere AIEEE 1981, yeah? And this question already we have solved in the normal session as well. Yeah? Right? So let's try to solve it again so that you master the concept of limiting reagent. Yeah? Because in this question, the concept of limiting reagent is involved. Right? Yes? Okay. So we will see how this question is to be solved. First of all, I'm given with a reaction. And I'm given with a balanced chemical equation. 3 times BaCl2 plus 2 times Na3PO4 gives this one plus 6 times NaCl, right? If 0.5 moles of BaCl2, so initially I have got some 0.5 moles of BaCl2 reacting with 0.2 moles of Na3PO4. So initially in the starting, I have got 0.5 moles of this one, 0.2 moles of this one. Since the reaction has not started because these are the initial conditions, so there will be no product formation at time t is equal to 0. So this is 0, this is 0, right? Right? The product wouldn't have got formed till now, right? Because the reaction has not started yet. The reaction has not started yet, yeah? Now guys, see. Am I given with the amounts of both the reactants? Yes, I'm given with the amounts of both the reactants, yeah? And whenever we are given with the amounts of all the reactants, what do we do at that time? We use the concept of limiting reagent. And what is the first step in order to use the limiting reagent concept? We are supposed to balance the reaction, and the reaction is already balanced. So first part of the equation is done. The reaction is already balanced. Now, it's time to identify which one is the limiting reagent. How do we identify that? Simple. Divide the given moles by the respective stoichiometry coefficient. So 0.2 divided by 2 is going to be 0.5 divided by 3, right? Yes? Yeah? So which value will come out to be lesser? Which value will come out to be lesser? See guys, 0.5 divided by 3, it's going to be 0. Something 166 like this, and it's going to be simply 0.1. Which value is lesser among the two? 0.1 is lesser, so Na3PO4 is going to be my limiting reagent, right? 0.1 is less than that of 0.166, right? The one which gets the lesser value, that will be my limiting reagent. So Na3PO4 is my limiting reagent. If Na3PO4 is my limiting reagent, Na3PO4 would have got completely consumed in the reaction. So I'll be left with 0 moles of Na3PO4 at the end of the reaction, yeah? What am I supposed to calculate? I'm supposed to calculate the maximum number of Ba3PO4 whole twice, the maximum moles of Ba3PO4 whole twice that can be formed. I'm basically supposed to calculate the moles of Ba3PO4 whole twice that has got formed, right? Yes. Now people, if you remember, as per your limiting reagent concept, entire product is decided by the limiting reagent. Which one is the limiting reagent? Na3PO4. Now I'll be using the stoichiometry of Na3PO4. I can say 2 moles of my limiting reagent, which is Na3PO4. 2 moles of the limiting reagent, it gives 1 mole of Ba3PO4 whole twice. 1 mole of Ba3PO4 whole twice, correct? Yes, I can say it. As per the limiting reagent, I can clearly say 2 moles of limiting reagent gives 1 mole of Ba3PO4 whole twice. Can I say 1 mole of limiting reagent gives 1 divided by 2 moles of this substance, right? But do I have 1 mole of limiting reagent, or I had 0.2 moles of limiting reagent? I had 0.2 moles of limiting reagent. If 1 mole of limiting reagent gives these many moles of Ba3PO4 whole twice, can I say 0.2 moles of limiting reagent will be giving me 1 by 2 multiplied by 0.2 moles of Ba3PO4 whole twice? This value will come out to be 0.1. So basically 0.1 moles of Ba3PO4 whole twice is getting formed at the end of the reaction. Is that something which I was supposed to calculate? Yes, I was supposed to calculate the moles of Ba3PO4 whole twice which are getting formed, and I got to know exactly 0.1 moles of Ba3PO4 whole twice are getting formed, right? Someone is saying screen is not clear. Well, screen is clear. The connectivity is all my side, all okay from my side, right? You just refresh your page once. Just give me some green signal from the chat box so that I'll get to know whether you got it or not. Yeah? Perfecto. Let's see if we have more questions or not. Okay, this is something which you all should tell me. People, let me know the answer of this question. The total number of electrons in one molecule of carbon dioxide. Is this something which I need to show? Yes, Namami. Yes, you can watch these. The total number of electrons in one molecule of carbon dioxide. Guys, do it. do it. And I'm sure majority of the students will do it wrong. No, majority of the students are giving it right. Perfecto. It's a simple question, guys. See, one molecule of carbon dioxide. One molecule of carbon dioxide contains 1 carbon atom and 2 oxygen atoms. What is the atomic number of carbon? 6. This is 8. This is 8. How many electrons are there in one atom of carbon? 6. How many electrons are there in one atom of oxygen? 8. One more oxygen, 8. 8 is 16 plus 6, 22. So in one molecule of carbon dioxide, there are basically 22 electrons, right? Yes. Shrey, you can check it, bro. The question was asked once. Yeah, you can check it. But these kind of questions, they are not asked frequently in the JEE. They are asked once in a blue moon, okay? This sort of a question, right? Okay? When the chemistry paper will be slightly tougher in JEE, at that time they provide these sort of 1, 2 simple questions so that you stay happy at the same time. Yeah? Thank you then, thank you. So people, with this, we end today's discussion, right? Okay, I'm sure you would have loved it. If you have loved it, do not forget to like the video. Do not forget to subscribe to the channel. And people, the best part is, do not forget to get enrolled in the pro subscription. Do not get enrolled. Do not forget to get enrolled in the actual Vedantu platform. Well, people, we have got a lot of things for you, right? The batch for the JEE 2023 people, it's going to start on 7th of June, right? 7th of June, the batch is starting, right? On the actual Vedantu platform. People, if you think Vedantu is only about YouTube, no. We actually take sessions on the actual Vedantu platform. And for that, you have to take one of the subscription. Yeah? And what all benefits you guys are going to have in this subscription, understand properly what I'm going to say. See guys, see properly. The first program is light program. Yeah? This is valid for 2 years. We are going to train you particularly for 11th and 12th, right? We are going to train you for the 2-year span, okay? For your class 11th, class 12th, so that you get prepared for JEE properly, as well as your boards, right? This is the course fee. Complete course fee is this much. And no need to pay this much in one go. You can pay this in EMI as well, installments as well, right? Vedantu has kept the option for it, yeah? And people, if you are new to the Vedantu, you have no idea about the actual Vedantu platform, Vedantu has created one more option for you. You can give it a try for a month. Yeah, you can get enrolled in this course for a month, right? You have to pay this much of amount for 1 month. If you're actually liking it, if you think you are getting benefited, then only go for the 2-year classroom program, right? You can give it a try for a month as well, like the demo classes, you can say. Yeah, this is one course which we have liked. Then we have got one more program which is classic. See, whatever features you had in light, apart from that, you get one additional feature over here, that is doubt solving on mobile app, yeah? So whenever you feel any sort of doubt, you just have to pen down that doubt in the doubt solving app. You'll be getting the answer at that time itself, yeah? And this is the course fee for 2 years, right? You're going to be with us for 2 years, right? Till you qualify the JEE Mains advanced, right? And people, this much amount you can pay in installments as well, EMI. And if you are new to Vedantu, you can give it a try for a month as well, right? This is the 1 month fee for this course, for this batch. Okay, you can give it a try, right? And people, the last one, which is the plus one, what is the extra feature in this plus one? First of all, the amount for the plus for 2 years is going to be this much. And again, I'm telling you, you can pay this much amount in installments as well in the form of EMI. It's for 2 years. And what all extra features do we have right here? You get the personal mentor over here in all the 3 subjects, yeah? Right? You get the personal mentor in all the 3 subjects if you are getting enrolled in this plus subscription, if you take this plus subscription. And again, you can give it a try for a month as well, no issues at all. You can give it a try, yeah, for a month. And if you're actually liking it, then only you can go for the actual 2-year classroom program, yeah? And people, how to get enrolled in these, or how to take any of these pro subscriptions, there's a link in the description box of the video. I want you guys to click on that link. Use the coupon code WBPRO. It's my coupon code, my personal coupon code, Wassim but pro subscription. If you are using this coupon code of either you use WBPRO or you can use WSPRO as well, okay? Any of one will work, okay? Either you use WBPRO or you can use WSPRO as well. One of the coupon code can work, right? Okay, and after using this coupon code, I'll be training you personally in your long-term batches, and at the same time, you'll be getting some 13% off as well while enrolling, yeah? So people, this was all from my side in the today's session. But before ending, let me tell you there is one more link in the description box of the video. That's for the Telegram. Do click on the link, get added to the Telegram group and stay updated about the classes. And at the end, the ones who have not liked the video, and please do like the video. Do share the video with your friends and do not forget to subscribe to the channel as well, yeah? Well, tomorrow I'm going to take the session for class 12 people, right? The session is going to be lecture number 5 from the chapter solid state, right? And people, day after tomorrow will be most probably starting the next chapter. You'll be getting the schedule tomorrow or maybe day after tomorrow on this channel on the community post, right? So stay tuned. Do not forget to subscribe to the channel, yeah? It was nice meeting you. Well, Saloni, you can go for OP Tandon if you are doing NEET preparation, yeah? OP Tandon is a good one for you, right? Yes, Namomi, tomorrow morning at 10:30 we'll be having lecture number 9 from the States of Matter chapter on NEET Elite. You guys can join in there also, no issues. So take care, guys. Take care. I'll see you tomorrow at 10:30 on NEET Elite channel. Till then, you take care. Bye bye. God bless you all and love you all. Take care, guys. यस सात्विक, हाँ जी हिंदी आती है मुझे, मैं हिंदी में ही घर पे बात करता हूँ. इट इज जस्ट दिस द इंग्लिश चैनल, तो मुझे इंग्लिश में बात करनी पड़ती है. सो टेक केयर गाइस, टेक केयर, बाय.